Hey folks, welcome to the stream. Um, be really nice. Sorry for the delay. It'd be really nice if OBS would quit forgetting what my settings are. That's kind of obnoxious. Don't change anything. I don't do anything. It just stops working. It's like, I don't know about the microphone. I don't know about the camera anymore. Anyway, here we are. So last time we left it off, we had gotten. So if you recall, let me get my preview up here. Yeah, they're just hidden. Okay, let's get these on screen. If you recall, we're doing kind of a clone of this game. It's a match 3 game, and the important bits that we've been doing have been around transitions between states. So, obviously, the easiest way to think of game logic in a functional style is like static states and like a function which transforms one state into another. That's not how it happens in a game. We have intermediate states which are not discrete. Like they're analog's not the right word, but they are transitions between states, and we have to represent those. So we made a whole transition data type, and that encapsulates the transformations that various objects on the screen are going through. And when those transitions finish, we actually have a thing where we can trigger that kind of discrete transformation, right? So we've been doing this. Last time we did this bit where the star that's coming in falls from the outside of the screen toward the board, and if it's not obvious from these pictures, if this is your first time to the stream, the mechanics are that if you have a star on an inner ring and one falls on top of it, falls in from the outside toward that, as long as this one is on the inner ring, then it'll land in the middle one. If you moved it out of the way, it would fall all the way to the middle, right? Okay, so and then as you rotate things around and you get them to match, they will be cleared from the board. The goal is to not just match individual pieces, but to match the pieces with the patterns that are on the board. So you want to manipulate the way that things are falling, or the way that things land on your board, such that you can match up the spots with the colors and shapes. So that's the kind of feel of the game, so to speak. And if you're like, navigation, what is this? This is from Yo-Ho-Ho Puzzle Pirates from the early aughts. There's a game I played a lot of, kind of a MMO thing. Okay, so this is what we're building. And after the stream last week, I discovered something. So what I did was we had added this spawn timer, which is like every so many seconds it'll spawn a new piece which will be falling from the outside, and then on this spawn timer, if the if the spawn timer has expired, so it's 0 or less, then we create a new piece, and we add this into the state of the game, right? So we have in our board state up here, we have this transitions, and this is all of our stuff that's like in flight. So it maps. We have a concept of entities, right? So it maps entities like a piece, so like one of the stars, or a ring, which is like a collection of them that are in that same part of the board, because you can rotate the rings so that you can align things. Anyway, so what we did was we added this spawn piece thing, and it picks a random position between 0 and 7, which corresponds to the different parts of the ring on our board. And we were doing this int random 5, right? And that was a way to pick a piece color. So the thing is, this wasn't really, how to put it, it was useful for the actual gameplay, but we weren't able to test some things. So off the stream, I set it to be only this type. So we're just going to do piece type 1. And here, let's run. We're going to do an upgrade of Tiramisu. But I want to show you this first, because Tiramisu was tagged in the last few days, which is awesome. So if we open this up, okay, so we had a starting animation, which is like, you know, just to show things. So pink is P1. As you can see, they're falling in. And when they hit the outer edge, they like blip in, but they blip over into two things. Now you saw the match there. It disappeared, right? We're not handling the issue where they run into the outside. That should cause game failed and no more spawns and so forth. But if we line up 3 or more here, you'll see the transition of them disappearing from the board. There are a couple interesting cases. So here, note that both of them disappeared. So this is our first bug. It should have fallen to the middle, and only the ones in the middle disappeared. But it took a pause right here on that middle ring, because it first landed in the outer ring, and then it fell to the middle, and then it fell to the inner. And those were on different frames. And we're evaluating the see, it happened again. We're evaluating the logic on every frame, or every time we go to, you know, process a transition or whatever. And so what was happening is it's pausing right here. That triggers a match, but it was still falling. And so it fell into the middle, and then triggered the inner ones to match and disappear as well. So did you see that? That should never have happened. So we got some logic bugs here that we're going to have to resolve. There's, first of all, and I think that we alluded to this on the last stream, we need to, if we're going to do this like discreetly, right, we need to run this twice. Run the drop twice. So the logic from I'm in this ring and I need to fall inward, need to see if I can fall inward, that needs to happen twice in one pass, so that we get, because you want the ones in the middle ring to follow the inner first, and then you want the outer ones to follow the middle. But then that leaves the case where it's in the outer and there's nothing below it, and it takes 2 frames to get down there. See it happen again. So we need to fix that. And I think it's just we apply drops twice. That would be the easy way. The other way would be to, I think, go around the ring, and at each position determine whether you've got, let's see, whether you've got, you know, one falling from the middle to the inner, or whether you've got one from outer to inner or outer to middle. So we could break it up like that, which would mean our logic is a little bit, I don't know, harder is not the right word, but we need to break it up differently, right? So, hi Chris. Welcome to the stream. I was just demonstrating some of the logic bugs we've got in here. So, yeah, you notice that one disappeared, and it shouldn't have, because it didn't match anything. But somehow it got triggered. So I'm just sitting here watching the pieces fall from the outer and land on the ring. So like, I think our vertical matches are correct. It's just an issue of when something falls from the outer ring to the inner ring and it's triggering too many. Hello. All right. So we're going to fix that. And hopefully it'll be straightforward. These things are never straightforward though, right? Like, that's the challenge. Okay. So, like I said, we could do, if we go to the definition, I'm going to have to restart my language server. Oh, the Gleam language server is not even running? Here. Can we restart Zed? Let's just close it and reopen it. Okay, I don't have any windows open. Open recent game jam. Okay. What is this restricted mode business? I don't care. Trust all projects. Thank you very much. Okay. Do we have the Gleam language server? Thank you very much. Okay, go to definition. So we've got this. What I was saying was we could do this twice, so that we process the other. Okay, I think that there's a possibility that we could put the outer to the middle first, but I don't think that solves it. So I think what I want to do is let's do we'll do a new function here, and what we're going to do is it's going to be 3 slots, right? And this is going to take inner slot, middle slot, outer slot. And I think what we want to do is a wide case statement. So we're going to do inner, middle, outer. And let's take care of the obvious ones first. So if we have none on all 3, we just return none on all of them. Right? If we have sum on all of them, then we return the input unmodified, right? Okay, so now we have the more interesting cases. If we have, so this is inner, middle, outer, so I need to think of it like coming from the right to the left. If we have the bottom one occupied, honestly, we could have this add the missing patterns. There we go. Okay. So if we have this, then there's nothing to do, right? Because there's nothing falling from the outer to the middle, nothing from the middle to the inner. I kind of like this idea of using, I was thinking earlier about like the idea that you want to follow in strongly typed languages is to make invalid states impossible to represent, right? So by doing this exhaustiveness, we can potentially remove the possibility that that other case would happen. Now this is not correct. We need to specify some here. which means we need to do this case again. And we don't have to do none here. It's just showing that, like, hey, there's no transformation to be made there. Yes, I cannot avoid functional programming. So here we're being more explicit that this transformation, the middle gets occupied by the outer one. I think that that's an important case. Now probably what we can do is, for the cases where, like, maybe let's put the ones where a movement actually has to happen up at the top. And then the other cases we can just say return the original, and we can eliminate some of the duplication here. So that would be like these two cases would be included. This case is like no transformation. Let's be explicit on this, because even though we can reconstruct that, I want to make it more obvious that those are no transformation. Okay, let's put this one up at the top. Okay, so we have inner's occupied, outer's occupied, outer falls to the middle. Here we have inner, middle are empty, outer is occupied, outer falls to the middle, falls to the inner, sorry. Okay, so this is an important one that we need to explode, right? In this case, we have the middle falls to the inner, and then the outer and the middle are unoccupied after. And the other case we need to handle is this one, which is middle, outer, none. So they both fall inward. Okay, and then that covers everything, and these are all the cases where something has to move. So I think that what we can do now is eliminate those cases and just return them unmodified. Okay. Sorry, I need to keep readjusting my seat. All right. Okay, so now I think that we can replace this with, instead of this, right? I think we can do let's rename this vertical. Execute, yeah, like, we'll just do that. We'll leave it for now. So we're going to have something similar to this in terms of what we construct. But we kind of have to explode it, and we have to do like the turn it 90 degrees and then turn it back, right? In terms of the data. So we're gonna do one of these business, and we're gonna do inner.a, middle.a, outer.a, and then we're gonna do that 7 times. 1, 2, 3, 4, 5, 6, 7, actually 8. And then wish there were an easy way to do this transformation, but we're just gonna have to bear with it. It's possible that this could be easier to do, but we can't really do it with a loop because these are named fields, they're not lists, right? So really, case where I wish my editor were more like Microsoft Excel, and you can just go like fill down, right? There's probably a way, I'm just not, I don't have the patience to figure it out right now. I do apparently have the mistakes to be able to pop up the emoji picker. Should have more emojis in my code, I guess. That's what it's trying to tell me. Okay, so now we have it turned on its side, but all of the things processed. So now we can say let inner is a ring. And do this because we're taking the first one, right? Okay, and we can duplicate that. We say this will be middle, and this will be outer. And here we'll do ones. So if you're not familiar with this notation, this is just taking the 0 through the first field of the tuple that we returned. If we had named them, we could have, you know, done that instead. I just think it's not important to define a new type here for this kind of internal operation. Okay, that looks right. And now let's see our game. Let's refresh. Oh, poo. Oh, it's because I restarted. That was weird. Okay. Okay. Let's watch it for a little bit and make sure that that logic doesn't happen. Advent of code vibes here. Yeah, a little bit. Sometimes just have to power through it. Okay, we still have that bug. Note that it... Let's watch it again. We can see if we can characterize it. Yeah, the vertical is fine. There may also be a bug in our horizontal match. We should look into that. You'll also note that I think because of the transition I'm using with the pieces disappear over time, that it's popping back, or rather the scale's going negative, so it's like flipping the geometry around. Okay, so that was actually correct. It's just that they fell into the middle instantly, right? So I think that was what I was seeing before. Or rather, it was the next frame, but it's like almost instantly from a human perspective. The main thing I think to watch is which ones get the scale out animation. Yeah. Okay, I think that fixes it. We'll have to monitor in a minute and when we fix the next thing. So okay, so I think that we can do that. Can get rid of this other one and the individual pieces there. Okay. All right. so our next bug, let's fix that transition. And I think it was probably over here is the correct place to do it, because what we want, let's see. Okay. I think here's where we were doing the exit. Yeah, so we need to if the tween goes past the end, we need to clamp it to 0 so that it doesn't go negative for like 1 frame. Because I think we were just getting the value here. All right, let's do another case. I hate doing it this way, but it's fine. Is complete tween. If that's true, then we just return 0. If it's false, then we return the value. And I don't know that that's going to fix it, but let's watch for a little bit. Float.clamp. The thing is, yeah, I can do that. That might be simpler. But because it's using a back out, no, they still appear. Okay, so there's a problem with it going past 1. All right, let's try the float clamp. We don't know how, I don't actually know what the peak of that function is, so we'll just say 2. Maybe for funsies, I should temporarily remove the randomness and have it just go around in a circle. Oh, they don't exit. Okay. No, that actually worked. The clamp worked. There's another slot there. I was misreading it. Okay, so there's still that bug. Did you see that? It landed in the middle, but this, and that exited. We need to trace that down. So if I had to guess, yeah, excellent suggestion on the float clamp. If I had to guess where that is happening, I think it's where we're adding the transition. So let's look at our main tick function. Where is our tick function? No, not advanced transitions. That gets called from the tick. It's a public function. Handle tick. Okay. Okay, so we're seeing if we can advance, or so we're seeing if we can spawn. We advance any transitions that are currently in process. I think we need to apply drops before we queue the matches. because this, when a piece stops falling, we place it in the outer ring. So it can still, in these one of these two functions, still match, even though it should fall to an inner one. So hello, what happened there? Go back, please. Okay. Let's move this up. So if it has landed in the outer ring, we should apply the drops immediately. Let's see what happens there. Okay, let's just refresh. It does feel really snappy when it hits the outer part. I kind of don't like that, but it's okay. I don't know what it looks like on the stream, but yes! Did you see that? It didn't match the one here on the right. It matched the inner ones only. Okay. Okay, I think that fixes that particular problem. Yay! All right, let's see. I want to see it do another one. Okay. Okay. And we'll tweak the transition timings on all these. Maybe a good next step is to extract those into constants so we can play with them at the top of the file rather than everywhere else. So, yeah, the colors, you know, I think I want to change it to have shapes also. The colors represent which pieces match which pieces. So, like, if you get 3 or more in a row or in a column, I guess it'd be a ray or a ring, then they will be removed from the board, and that should add points to your score. But ultimately what we want is not just for them to match 3, but also match the patterns, and we just haven't made a display for the patterns yet. That might be a good thing to do next. It will involve some math, doing lots of trigonometry in this one. It's a lot of math. Okay. Cool. Okay, so I think that solves that particular problem, and this is a good place to make a commit because I haven't made one in forever. Let's do it in this panel instead. Okay. Yeah, stage that. We're gonna do our. I think we're gonna do our tiramisu upgrade next, and we need these two things. And did you, sorry, this is a question for Renatius. Did you perhaps expose that texture thing that I did the FFI for last time, the RGB color space? Is that available in Savvy already? Okay. Oh, no problem. No problem. We will, maybe we'll make a patch. It's fine. Fix logic bugs on falling pieces. Okay. And this is going to not succeed when I push, but I don't care. Oh, okay. Here's a problem I need to do. I forgot. What is? Sorry, I'm gonna have to do this off screen potentially. GitHub. I made a change to my GitHub settings in the last week that requires me to change what my commit email is. So let me see this. What do you have to do? There it is. So I need to change my, this is probably better anyway. I need to rewrite that commit. Let's say reword. Okay. The question is, will it update? Because this is like my personal email address. I wish they'd had this feature years ago, because like, hey, easy to scrape people's email addresses from GitHub. Okay, let's try this. Yeah, it didn't change it. I think I can amend. Let's see what we can do with help. Like you can reset author. Yeah, let's do that. Okay, now it's got my, okay, now we can push. Sorry about that. That was a little bit confusing. By the way, if you have this feature, it's actually on GitHub turned on. Or if you don't have it yet, you should. It's pretty nice. I always struggled with the, like, when I changed jobs and they were using GitHub for code hosting, and it was like, oh, well, am I using my personal email address on commits or my work email address on commits? And if we use this generic GitHub one on commits, that's better. Okay. So now we've got that taken care of. I got too many windows here. All right. So let's, while we're here, let's upgrade Tiramisu. So we had done this last time. We've done it like twice already, but we were jumping to, yeah, like this. So I think we can do this, and then, yeah, I know there's a Gleam update, please. And here we're gonna import. So we use the published version. Okay, so mascarpone, yeah, we need to update that. So is it 3.0? Hex mascarpone 3.0. Okay. We can probably use the Gleam outdated as well. Let's see if there's any, what is it? Gleam hex outdated? No. Let's see what it is. Gleam depths outdated. Okay, that didn't error, so we know that's the correct command. Yeah. Okay. Thank you. Thank you. All right. I'm seeing a warning, but I'm not seeing any. Okay, that's just that we're not using that. That's not a big deal. We can fix that. Not seeing any compilation errors. Let's run our test real quick. we can, let's clean. Yeah, we still got some things that are, I'm not using the paint package, but it's a dependency somehow. Okay, no problems with the test. All right, upgrade to latest tiramisu. Mascarpone. Okay. Cool. So let's take a moment, and now that we've got that going, yeah, I need to restart the server. Yeah, this was easy. Partly because I'd done all the hard work a couple weeks ago. You haven't changed the API much since then. Okay. So I want to do a little bit of cleanup here and make some constants, which are transition durations up here. And I think that I have... Yeah, so our rotate. So let's extract that. Let me rename this one to piece milliseconds. Wait, that's not right. This is the ring rotation. Okay. We'll do that in milliseconds as well. Let's find out where else we're doing this. It says seconds here, but like we can do duration milliseconds very easily. Let's go ahead and replace that. There we go. Let's put this in a constant up top too. And let's say milliseconds so that we can get finer grained on it if we want. So let's say const piece spawn timer milliseconds. I think that was 3 as well. Yep. Okay. Let's find the other tweens. Okay, here we go. So this will need to extract into a constant. Is there a code action for that? Yes. Where did you put it? Go to definition. Okay. Let's move this up to the top. This is going to be piece fall duration milliseconds, except I need to just do the rename. I don't think I needed to declare the type on these. It's kind of nice to do it, but not necessary. Okay. Okay, so there's that constant. Okay, we've extracted those all as constants. Good deal. Let's find all the places we're calling duration. Okay, that's just the type. That's fine. Okay, I think we're good there. That's a good thing to do. Let's refresh, make sure we're good. Obviously, the ring rotation, we don't want it to take 3 seconds. I think that was our initial thing to show, here's what it would look like if that thing rotates. So we probably want that to be more responsive to the player. I think the spawn timer and the fall duration are fine. We can probably make those closer together and actually have things spawn faster, or have it be something that we amp up over time. I'm just putting some stuff in here. Okay. We can get rid of this. Okay, and I'm trying to remember what the other bug was we were trying to solve, but I feel like we maybe don't need to. Okay. So let's look at the transitions. We've handled exit. We don't use this drop transition, and I'm wondering whether we should even have it, because we would need to understand where the piece is falling from, where it's like what ring it's dropping into. You know, that's actually not so bad. It's just a question of whether we want them to, like, here, I'm going to close everything else. Whether we want it to delay the logical drop. Because we did that, you know, we made sure to put this before the matches. Now what we could do is here, rather than forcing them to drop instantly, right? We could make sure they stay where they are. I think the challenge with this is if we say, like, let's say something completed, and it's completed falling from the sky, and it landed on the outer ring. It landed on the outer ring. Let's say there's two other pieces on that outer ring which would match it, but there's at least one hole below it in the board. We don't want to cue that horizontal match, right? Because it doesn't match. That state is invalid. But but having it fall instantly, like pop, like that, right? It's very poppy. It's a little bit unsettling. Even if it is logically correct. So maybe what we do is the thing that's challenging about this is we're probably going to have to change our structure such that we either don't apply matches if the thing is already falling, so like invalidate it, right? Or we kind of have them fall and disappear at the same time. So the other possibility is that we could make a queue of transitions where we only, like, we process them in order, right? I think right now I kind of want to defer that decision. So I want to just let it be a little bit unsettling right now. And then we can handle whether this is a thing we care about later. Gosh, thank you for that float clamp suggestion. That worked really well. Okay, let's leave it. What I think I'd rather do with the rest of the time today is get the controls working correctly. So we'll need a way. Let's see in the board. We have the selected ring, so we can. We should be able to translate some user input, and I think we need a way to show that it's selected, which I think is like a color or maybe a luminosity change on the color. Okay. Well, maybe let's do that first. Let's make it appear correct. So we're going to need to pass in to the rings which one is selected. And this is board.selected. Okay. So it means we can't reuse this material, unfortunately. We're going to have to make a new one and like pick a different color. or a different roughness or something. Let's do it this way. Let's pick a constant. I don't know. Let's make it like super high contrast from what we had before, because we had blue, right? Let's do dark yellow. That's gonna look awful, but it'll be fine. And let's just copy those things. Okay. And now underscore, please. Thank you. And let's just copy this and modify for the other two. So what I'm doing here is just saying which one is selected, and matching that up to the thing I have here. Obviously, I could make this like a little function. Yeah. Okay, so now you can see that the inner one is selected. It looks disgusting. Let's do just yellow. Just plain yellow. Okay, it's a little bit more lemony and a little bit less. Yeah, I don't think that that's what we're gonna keep. You know that what they did, and maybe we can do this later. What they did is they actually put, so it's kind of flat when it's not selected, but when it's selected, it's got this kind of highlight texture on it. We could do something like that instead. Okay, so we're now displaying. Let's make a commit. I have this problem working on this project where I'm like tweak, and I don't make any commits. So let's have a look here and do that. Okay, so yeah, let's do this separately. Extract transition duration constants to top of file. And then this one we're going to say highlight the selected ring. Okay, cool. All right. So let's go out to the top level, because I think that what we did was we did not handle user input. So I think we'll want to change these things out, but let's have a look at the Tiramisu documentation for a moment. 7.0, woohoo! Okay, so we were doing stuff with the bindings so that we could make it configurable later. Where we did a whole bunch of stuff with like defining the actions that people take, they can take, and then binding those to, either keys or buttons by default. And then I, did some jankiness to this. I don't remember what this UI user. Okay. So we need to do this step. And I think let's look at this, because we've got the bindings. We probably want to do input buffering, but maybe we won't do that right away. So we did one of these things. The question then is, like, do we just need to go through each of these actions and check if they're bound? Like they're being requested. Okay, that's interesting. We're not using buffered input yet. Get action value. No. Okay, so we could do this is action just pressed for some of our stuff, right? Let's do controls, say like handle input. And we're going to pass the board here, because what we want to do is to call the core. Maybe what we'll do is like controls dot handle input and pass the context dot input state. Okay, so let's make that function. I think, why was I distinguishing these continuous? Oh, I already did this. Okay, well, so what we need here is also the game state, right? So let's go, and I don't really like to couple all this stuff, but we had done this thing, I was thinking ahead when we did this, but it's just like take the input state and the bindings. So we actually need the model input, context input. We're going to pass those things. Right, because what we want to get is what actions do we need to perform, and then we'll flip through them and process them one by one, transforming the board. Okay, so let's just put it here, handle input. And I could potentially just pass the model, but I'm a little bit worried about coupling the wrong direction. So This is going to be the state, which is the game state. Okay. And it's going to be the bindings, which is I'm surprised I didn't make a type alias for that. And then the input, which is the, what is this type? Okay. And what we're going to return, and this actually takes the board as well. Board. Okay, so we're going to transform the board potentially. And let's just put a do here. Okay, so we need to first look at what the game state is. And I think if we're one of these three, we will probably want this to have effects as well, but we can deal with that. So I think that if we're loading, honestly, if we're loading, we should do nothing. But if here's where we would do menu actions. Okay, so we're going to say this is going to be let actions. We're going to decide what kind of actions they can perform. Might reorder those arguments. That probably doesn't matter as much for JavaScript. Okay, so if we're in game, then we want to do gameplay actions. Okay, so this is going to be a list of actions. So now I think the thing that's subtly different here is that these are sort of like abstract user input type things. We need to potentially change not just the board, but the game state. So I think that this is the slightly wrong approach, because what we want to do in gameplay actions, like when we're in the game, is different enough from when we're in the menu. Because I feel like these, aside from toggling the menu, which would be like change the state, put it back in game, if you hit, escape or whatever. That yeah, I think we want to process these differently. Let's do this. And I think here we're just gonna, I'm gonna no op this for now, and we can deal with that later. Because what I'm concerned about right now is making sure we process the each of the actions properly. Okay, so let's do a we're going to fold over the actions. Okay, and then we're going to do okay, so this is actually the function is going to take the accumulator and the action. There we go. Let's put a to do there, and let's figure out what the type problems are. Oh, we need to reorder that. Okay, now it's just saying, hey, it's unused. Okay. So now we can add these patterns. So when we're in game, move up will be, we're going to make a function in the core, which is going to say move selected out. That doesn't change the state. And then move down will be move selected in. And we'll just keep that state change in there. This is just translating the input actions. Okay, move left is core rotate. Let's see how we want to do this. We'll call it rotate left. I'm going to make a new function for this. And we'll do the user rotate right. Okay, menu toggle is going to be the board doesn't change, but what we want to do is go to state paused. Okay, that's not so bad. Got an excuse to use the use statement, which is fun. Probably not completely necessary, but here we are. Okay, so let's go define these functions. Let's see if the code action will generate function. Hey, how about that? Okay, so what we want to do is say board dot selected. We're going to add missing patterns. So if we're moving outward, then what we want to do is we want to splat the original board, and selected is going to be middle. And we'll do something similar here. Outer. And then here, it's just unchanged because you can't move beyond that. All right. Let's do the same here. So inner is just going to return the board unmodified. And we'll do board selected outer. No, inner. We're we're moving inward. Okay. Okay, close those. All right, let's generate that function. Okay, so what I need to do here is do we need to get the board transitions. Sorry, getting ahead of myself. And we're going to do the ring entity for the selected board, the selected ring, right? And I think if we've got a transition, we don't add one. And I know that that's like probably doesn't make sense yet. But since we're not doing input buffering, we need to make sure that if there's an ongoing transition, you can't queue another one up, right? Or you can't replace it immediately. Because then you can get into jitter things where it's like you press it so fast that the transition didn't have time to finish, and like it queues that same thing up again, and you just, you know, twitch. That's not good. Okay, so here's what we'll do here is we're going to say I'm going to extract this because we're going to reuse it. Board.transitions entity, and then we're going to go row where did we let's just save and go over here, because I think that we did oh, right. So we need to construct, this is the tween. That's fine. We constructed one when we started the thing, right? Okay, so we need to say rotate ring. That's the thing that we're putting in there. The repo in the description is not public. Is that on purpose? Did I not make it public? I thought I did. Sean Cribs. Let me see my apologies if I did not make it public. It says public, Gleam Game Jam 2025. There's a typo on the link. Oh, okay. Yeah, I'll fix that. Just the YouTube description. I'll fix that. Sorry about that. Okay, so I need to do this. I probably threw him at the bottom. Yeah, okay, so I need to do this, and the direction needs to be left. Thank you for calling that out. I'll go fix that on all the descriptions. And let's go ahead and generate that function. And then we basically have the same thing here. It's just the difference is this is right. So maybe there's something we should extract there. Yeah, let's go ahead and do it. let's just copy this and the direction. And then we will say simplify those two things. Honestly, I could just pass it as an argument, but it's fine. And when I say pass it as an argument, I could call user rotate and just import the type. But okay. So the other thing I want to do here is actually not let you toggle right now. Because I want to make sure that all those controls are correct before I do that here. Okay. Oh, right. So here's a problem. This is board state, and we need to update the state here. It doesn't happen yet, but okay. So I got that wrong. It's jumping incorrectly. The rotation's really slow. Let's fix that. Okay. Let's fix the rotation. That's hilarious. It's still this. So I probably want it to be more like 250 milliseconds. Yeah, that feels pretty good. Maybe we could make it even a little bit shorter. You can't see, but I'm hitting A and D. The problem is I'm getting that I'm pressing the key once, but it's happening twice. So I think there's either a problem in yeah, let's look at our controls here. So the gameplay actions. All right, so these are listed as continuous. And I actually think that that's too twitchy. And I'm going to move them all in here. I know that there's a thing where, yeah, see, now it works. That transition, now that we have a lot faster movement on our yeah, this needs to be more like 500 milliseconds. We can close that. We're almost there, folks. This is great. Like, so the controls are working. That feels good. Like, there's still, you know, it's not perfect for sure. But that, you know, that's a little bit snappier. Let's maybe even bump it down to 300 milliseconds. And see what happens. One of the things I think that happened in the original game, I'm not 100% positive, is that it was, as you got better, the pieces started spawning faster. Um, but you can see like how what you have to do is kind of plan where something is going to fall, um, such that you can align it in a way that uh, fits the patterns. So like you have to think about, how many slots is it different from the piece that I already have on the board, and and so forth. And that's part of the challenge. Okay, so I think this is a good. We've got some controls fixed. This is good. Um, Implement basic control. Let me see. It's not implementing. It's just hooking him up. Okay. Yeah. Okay. So now I think let me clean out some of the things that were just there for testing. So for example, we're just gonna always do they're always going to start empty, right? Okay, and then our spawn, we're going to put this back. We can put the random back. Okay. Yeah, we're gonna have to pick a different color for the selected ring. I'm just really happy it's working, you know. Feels good, man. Yeah. Oh, thank you. That's very kind. The thing that I struggle with is like, it took me so long to get to this point, right? I mean, I know that's kind of like game development, but well, that was a weird interaction. Did you see how it was exiting and then I ended up flipping it as well? That's a little bug. Obviously, we're not pausing gameplay when we go into the failed state. What we should do when we go into that state is like reset the board. And I think that there's a thing where it's in advanced transitions where if something falls and yeah, we go into the failed state. So yeah, maybe what we do next is the interesting thing about this is we essentially have a bunch of systems in this file, right? And unlike how you do it in Bevy, where you would handle each system individually and like schedule them, we're kind of, it's just run through the thing. So maybe what we can do at like after all of this stuff is applied, we need to have something. I'm just put in a comment here. We need to it's like check state. It's the wrong word for it. But basically what we want this to do is if the board is solved, clear and regenerate patterns. So that's one thing. If the board is failed, so like here, we had processed, like one of those things fell in and it hit an outer one. So like that's in the original game, they would have called that a booch. You booched it. But that's, so if the board is failed, we want to clear entire board and start over. So if the board is solved, we want to clear the matches, right? Clear the pattern matches. Okay, so I think that what we can do there is this is less of a check state and more of a we'll do Q pattern matches. And then we're gonna do we'll call it clear failed. Okay. So let's go ahead and generate those functions. Okay, so the clear failed will be easier. This is a board. Okay, so if you're plain, we just do no changes. If we're failed, then what we want to do is say we don't want to change the user's selection. But we want to reset the board. So we're going to clear everything out. Yeah, so we need to do we're going to remove that transition. We're not, and this will be next piece ID will be 1. That's one thing I didn't fix. Okay, so there is a function in here. I forgot what I called it, which is what did I call it? Did I remove it? It was sort of like a board solved. Here, let's leave that as a to-do so we don't mess things up. Oh yeah, there it is. So we can check board solved. Okay. If that's true, so if it's false, then we'll just return the board unmodified. If it's true, then we're going to do the I want to rename this. Check solution. Okay. And then so what we want to do here is we want to keep the same board. We want to I don't know what we need there yet. I need to make this into a block so that I can do a couple things. Okay, so we're going to make some new patterns. And in this definition of this board type, we have the pieces and the patterns, right? So we're going to generate some new patterns. New patterns. We'll make that function in a minute. Okay, so the patterns are going to get replaced. Generate that function, please. Okay. And we'll do some randomness in there to pick, you know, like pick a certain number of things. Okay, and then what we need to do is also update the pieces. So we're going to do we need to update the transitions as well, because what we're going to do is we're going to make the pieces that were matched by the patterns do the exit animation. So let's do we'll call it Q pattern matches, and we'll just pass the board, because okay, so this is going to be, we want pieces and transitions. But honestly, we probably just need the pieces and the patterns. There's a question here in my mind whether this, and we'll do dict merge board.patterns or board.transitions with transitions. The problem here is we could do board solved when there's no patterns at all. So we're going to have to generate some patterns to make this like not be psycho. Okay, so here, I think what we want to do is go through each. I'm going to destructure those. Yeah, I know they're both P. It's not a great name. Outer P pieces. Okay. So, okay, so now I need to go through each ring. You need to group them by the ring name, right? And we need to go like inner P, middle P. There's a lot of like changing the structure of these things around and so forth that happens in this logic. Okay, so what I'm doing here is I'm matching up the patterns to the rings. And I think that what I need to do is the interesting bit here is we don't have to change the pieces. I think we just need to get the transitions because they're not removed from the board yet. They've got to go through that phase, right, of executing the transition. And I think what we can do let's just do a flat map and we'll make a function here. And then we'll do I almost want to do a use here. But I need to pipe it to something, so let's see. Dict from list, can you do that? No, okay. So what we'll do is rather than flat map, let's do list fold into a new dictionary. And this is going to be, we'll call this transitions to be consistent. Okay. Sorry for all of that craziness, but yes, we don't need to update the pieces. So now what we need to do is take so each of these patterns is a ring. Early on in this thing, I had this like ring to list, list to ring, and it was bad. It was super inefficient and pointless, and it was just so I could do some of these like this list fold stuff, and I switched to the named slot type of thing, so that certain things would be simpler, like these splats with updating a piece. That was a lot simpler when I did it that way, rather than have to turn things in a list, insert it in a specific spot, turn back to that. Like that was just a mess. So I think what I want to do here is like we'll make a little function which handles, given a pattern and a piece, what do I do? Do I insert a transition or not? So it'll return a dictionary, or we can pass it the dictionary and it'll just insert it. Yeah, let's do that. Okay, so let's do so we're going to take transitions and we're going to pipe it to Q pattern match, and we will do patterns dot a pieces dot a, and we'll repeat that for all of the slots. That's 5, 6, 7, 8. Okay. And here we are doing this same substitution again. Makes me wish I had a macro. It's okay. Okay. So generate that function. Okay, so we have this. This is our transitions. All you need is Vim, I know. Fair. Pattern and piece, and we have a type for this already. It's called slot. Okay. So if we have no pattern, it doesn't matter. We just return transitions. Actually, let's focus on if we have a pattern, and the pattern has a piece in it. So the piece, okay, and we have, and let's do this. We've already determined that it does match. So okay, so we're going to do P, this is piece entity, P.id, right? We're not checking whether the kinds match up here. By the way, how do you find in Gleam for making a game? Honestly, way better than I expected. Like the things I struggled with in Bevy, some of it was like not having the right ideas. This, I feel like I didn't invent the game design. I'm just implementing it. So I think it's a bit easier to know what to do. It's also got a lot less scope than Bevy Survivors was that I was trying to do over a year ago. Um, so that's not um, that's not a problem. Um, Certain things are easier because I get to think about logic more and less about the mechanics of how to schedule things. I think though, doing with through this experience, I feel like I kind of broke through a bit of the understanding of how do you do things continuously versus discretely, and there's still a lot of discrete logic here. Um, but I feel like I can sort of get a better sense of um, let's make this thing um, happen on a particular schedule. I mean, schedule in terms of timing, and make that timing of a particular transition cause the state to change and feel more confident about, yeah, I'd made that state change correctly, than before, where I was like, well, everything's kind of, wishy-washy, or everything's super strict. And I think the super strict is actually way easier. It's just this kind of middle ground that I'm learning how to deal with. So let's finish this up. Pig piece exit transition. Okay, now here's a problem that I didn't know that we needed. This. So we're gonna have to do. We have to put the name in here. And that takes int is the position, right? Yeah. Okay. So this is going to be ring name. And then let's pass that. And we'll pass an integer, except that needs to be 0. This is kind of dumb, but here we are. I think the biggest takeaway is you sometimes just do dumb things to make it work. Okay, so this is ring name, which is going to be ring name, and this function is getting a bit big. And this is position, which is going to be an int. I don't remember why I need those in there, but and then for anything else, we just return the transitions unmodified. Okay, what did I do wrong? Why are you mad? Oh. Okay, so I actually need to just do this, where it is a pattern. Have you dealt so far with dispatching effects in the game? It can help decouple and think more of events that have happened and that you would want to deal with in the next frame. Yeah, I mean, I sort of... I could do that, potentially. I'll be pulling it out another layer, like out of the core logic. Yeah. I mean, I think with this not being tied up in effects, like effect is kind of an opaque wrapper, right? So I probably want to do, in terms of being able to test the logic, like I could jump out here and go like set up a board that is solved, and then knowing where all of the pieces and the patterns are, I could go and make a test that goes, did I queue up transitions for each of those pieces that should exit? I think that's a really straightforward thing to do. Oh, and this is board. I don't know why I did A there. Okay, so here we need to implement this. Now this isn't just empty rings, so we need to do new patterns, and this is going to cause a panic because we have to do in there. Okay. What did I do wrong? There's a bugaboo here. Okay. That was weird. Okay, so let's have a look here and like get a heuristic. You can see in this first frame that I captured from this video, there's 1, 2, 3, 4, 5, 6 patterns. Here there's 1, 2, 3, 4, 5, 6 again. 1, 2, 3, 4, 5, 6, 7. Note he's further along. The player is further along in their progress. So there's more patterns. Let's start with 6. And I think that we can probably do this greedily and like have it pick just have it pick 6 spots. So let's generate a pattern, which is going to be it's going to pick a ring name and a position, which is an int. That's pretty straightforward. Okay, so we'll say name int.random, 3 of them. 0 is going to be inner, 1 is going to be middle, 2 is going to be outer, and anything else we can do panic as invalid ring name. Okay. Random ring name. There we go. That'll be easier. Okay, and then we'll say let position is random 8, and we have done something like this before. Where's our spawn? Actually, we didn't do that. So the other thing it needs to do is pick, we did do this. We do need a kind. Okay. Generate. Okay. So this is going to be a piece kind. And let's make that last. Okay. We're going to return name, position, kind. And actually, we don't need to do a case on that. Okay. So there we generated one pattern. And I think that we need to do like something like a fold while, or we could do a tail recursive function. I don't want to pull in the yielder business because I think that this is like an unfold where we're trying to generate a set. Okay, so I think we'll make a generate patterns, which is going to take a set of these things. And a count. And it's going to return a set of those things. So what we'll do is we'll have it be tail recursive. So let's do case generate pattern. And we actually want to do case count. If it's 0, then we return the set. If it's anything else, then we're going to do here's where we'll do new pattern is generate pattern, and this is like a fallible thing where if set dot contains new pattern, then we will, if it already contains that, then we'll just call generate patterns again, count. Otherwise, we will call and we're going to do set dot insert new pattern and count -1. So typical tail recursive thing, and I'm just avoiding using like an unfold type thing, so I don't have to pull in that business. Okay, so now we can say like we're going to say let patterns is going to be generate patterns. Okay, and then ultimately what we need to do is let's look at that place piece. And this is kind of what we want to do. Excuse me. Okay, so let's do use rings, and this is going to be ring name, position, kind, and we're going to list fold over over the patterns, new rings. So we're going to make a new empty rings struct. And then we're going to go case ring name. And let's do add missing pattern. Oh, for Pete's sake, it just doesn't know what that is. we need set to list. There we go. Now it should know what that is. Okay, so we are going to, we need to kind of generate a piece for that. It's just a kind and ID, so I'm going to make a new function called place pattern, which makes use of that place piece. And it's going to take rings.inner. So it's going to take a ring, and it's going to take position and kind. And then we will duplicate that. And this will be middle. Okay. What's wrong there? Save, and then let's see what. This doesn't return. We're doing fold, so what we should be returning is the accumulator, right? Oh, new rings function. Okay. So now we need to generate this function. And this is the ring. And this is going to be let okay, because we're going to place piece. Okay, what does that take? It takes the ring, position, and we need to do create a piece which has ID 0 and kind. And then return ring. That was simple enough. What's wrong here? Let assert. Okay. So generate patterns. Oh, right. So we need to give it an empty set. And we need to give it, we want to do 6. And we can change this up later based on like if we want to make it harder as the game goes on. But let's extract that into a constant and rename that to pattern count. And let's put that up at the top with the rest of our constants. I did this a lot in Bevy too. Like I think it was a pattern. It was a thing that was pretty common to do, which is like make a bunch of constants at the top of the file that you deal with. Okay, it's probably not going to compile, but let's see. Yeah, we've got issues. Okay, it's still placed, no patterns. Or rather, we can't see them. Actually, probably placed them, but we can't see them. So maybe we can take a few minutes and do that. A few minutes is probably going to be like more. Okay, so we got pieces. Let's make a new function here, which is patterns. So this is going to return a list of scene nodes. Okay. So let's do, let's make a, not a ring geometry, let's make a pattern geometry. And we'll do it similar to what we did for piece geometry. And then we'll do, this is going to look really similar to the other one. Inner, middle, outer, and this will be board.patterns. And then we'll do this thing again. Another place where we're changing the orientation of the dimensions. Core.outer. And I'm gonna try to remember to do a screenshot. Okay, so we're doing a bunch of, yeah, we're gonna make a scene ID here. Ring pieces, ring patterns, ring name, and we'll say pattern will position, which is in the end. Let's do that, and let's make missing patterns. Ring patterns. Patterns, and this is name, ring name to string, and this is name and position, and we'll do patterns or pattern, ring name to string. To string position. Okay. Is there a code action for sort those? There does not seem to be. Okay. Yeah, because I think what I was doing here is I was mapping these two. So ultimately in here we want to do scene dot empty, and the ID is going to be we need to do this at the top. Is going to be ring patterns. Ring name. Yeah, I don't need to like make sure that I import all of those. Ring pieces, ring patterns, pattern. Okay. Maybe I could make a group transform and the children are going to be patterns. And we'll just make let patterns is an empty list right now. Okay, I think that this is a good place to stop because I'm kind of running out of steam. And we will follow up on this next time. So thanks for hanging out, and we will maybe even have more of a functional game next time. Thanks a lot.